We are going to look at the synthesis of a carboxylic acid by carboxylation with a Grignard reagent. So what we're going to do is we're going to take a Grignard reagent, which you have made previously. So if you need to review the mechanism for the formation of a Grignard reagent, do that. But you could start out with any old alkyl halide that you want. And that first step would be to make that Grignard reagent. So you would use magnesium in an organic solvent that does not have an acidic proton, something like an ether. Once that Grignard reagent was formed, you would add carbon dioxide. And this is usually gassed in. You just put a chunk of carbon dioxide, solid, dry ice, put it right in there. And then after that has been allowed to react, you would add in an acid source. So this is a three-step process to get this reaction to occur. But again, like I've said, you should know the first step for this mechanism, so I'm not going to go through it. But it does allow you to make the carbanion that is associated with the magnesium and the bromine. I'm going to write it this way, but that would be equivalent to drawing it this way. I just like to see the separated ions. Now, once you have your carbanion and you add in carbon dioxide acts like any other carbonyl compound. You have a carbon with double bonds to oxygen, so the oxidation state of that particular carbon is quite positive. And it can act as the electrophile. It will act as the electron pair acceptor. So your carbanion will take its pair of electrons and add to the carbonyl carbon. And as this occurs, you will break one of the pi bonds. Now, what you get from that is a carboxylate. Now this carboxylate will stay in solution just as it is, and it won't do anything else. It has resonance stabilization of its negative charge. And this is where it will stay until you add the acid. Now the acid source that you can add at this point can be an oxy acid or a hydrogen halide. It tends to be a bit dilute, but you just basically have a proton available. And there is resonance stabilization of the carboxylate, but one of these oxygens will come in and pick up a proton. You'll give electrons back. And in the end, you've made a carboxylic acid. And we've got our ions. These are just spectators over here. This mechanism shouldn't really be anything new to anyone. There are a few important things to think about as you look at this. Number one, you are making a carbon-carbon bond between what was the carbon attached to the halogen and the carbon of the carbon dioxide. So there is a carbon-carbon bond made here. And that's important that you realize there's a carbon-carbon bond made. Another very important component of this reaction is that you do use a Grignard reagent in that first step towards the carbon dioxide. And as a result of that, you need to be aware of what may be incorporated somewhere else in the molecule. You cannot have any OH, NH, or SH groups because Grignard reagents are very strong bases. So if there is an acidic proton, you'd go for the proton before you would do that nucleophilic attack toward the carbon dioxide. So that could be an issue. Also, you cannot have any other carbonyl groups present because Grignard reagents are not specific for just the carbonyl carbon of carbon dioxide. They go for any carbonyl carbon. But one thing you can do with other carbonyl carbons is protect them as acetal groups. So you could protect those and then do this reaction and be okay. But you cannot do this reaction at all if you have an acidic proton anywhere in the molecule.